Assalamualaikum. My name is Syed Fuad Iskandar bin Syed Amir Sharmin from Group 1. The topic of the experiment is PELTON wheel turbine efficiency. And this is my group member. Okay, the introduction. A turbine is a rotary mechanical device that extracts energy from a fluid flow and converts into useful work. The work produced by a turbine can be used for generating electrical power when combined with a generator. A turbine captures the kinetic energy of fluid motion such as water, stream air, or combustion gas. A flow impulse causes the blades of a generator turbines to rotate. In this study, a PELTON turbine is applied in this experiment. PELTON turbine is a tangential flow impulse turbine in which the pressure energy of water is converted into kinetic energy to form high speed water jet, and this jet strikes the wheel tangentially to make it rotate. The PELTON turbine has a fairly simplistic design. A large circular disc is mounted on some sort of rotating shaft known as a rotor. Mounted on this circular disc are cup-shaped blades known as buckets evenly spaced around the entire wheel. Generally, the buckets are arranged in pairs around the rim. The nozzle are arranged the wheel and serve the purpose of introducing water to the turbine. Jets of water emerge from these nozzles tangentially tend to the wheel of the turbine. This causes the turbine to spin as a result of the impact of the water jets on the buckets. Okay. The problem statement. PELTON turbines are available in range of size. As a result, the rotational speed and moment of the wheel shaft may be altered, and it depending on the link variable. The PELTON will output power and efficiency change. The the variance in wheel efficiency must be measured or calculated. We can assure the optimal utilization of the PELTON wheel by assessing the influence of the variable on maximum turbine efficiency. Objective and scope. The objective of this experiment is to measure a PELTON wheel turbine power output and compare it to the theoretical power output. Second, to investigate the operation of a PELTON wheel. And the last, to evaluate turbine scaling laws. By measuring the volume flow rate, pressure, rotational speed, and shaft moment, this experimental lab can calculate the turbine input energy and output power. Based on the data, we compute power input and output, as well as efficiency. To see the link between calculated variable, we can create a graph using a tabulated result, and we can add up the result and observation. That's all from me. Thank you.
Good morning to everyone. My name is Stanley Sirin and my metric ID is MA18144. So today I will be presenting for the chapter 2 part of this experiment, which is the theory. The purpose of this investigation is to study the relationship between the speed of the Pelton wheel, the power output generated at a constant pressure, and also the flow rate. The Pelton wheel is a hydraulic impulse turbine in which one or more water jets collide with the bucket mounted on a wheel. The impact that is produced from this will generate torque, in which will cause the wheel to spin, and this will in turn provide power. The power delivered by the Pelton wheel can be calculated from the speed and the cross-sectional area of the jet. The following are the equations that will be used in this experiment, such as in order to obtain the power, mechanical power at the output, we will be using this equation, and where torque will be multiplied with the radial speed, and the same for hydraulic power at the input, where the pressure will be multiplied with the flow rate. The equations such as the radial speed will be using this equation, and the turbine efficiency will be using this equation. That's all from me. I will pass the next presentation to my other group member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shazwan bin Ahmad Sahimi, metric number MA16106. So today I will present about for chapter 3, which is for methodology and procedure of this experiment. Okay, first of all, the apparatus that we use to conduct this type of experiment is PELTON turbine, which is the part of this turbine. We have first one, the spring balance, manometer, nozzle adjustment, nozzle, Pelton wheel, and last one is brake adjustment. Okay, next we go for the second apparatus here is hydraulic bench, which contain the first one is flow control valve, second overflow, the third one is storage tanks with pump, the fourth one is valve, next measuring tank level, and this last one is measuring tank. So we can take a look on the experiment apparatus that we have used in this experiment, which contain about 12. First one is spring balance, manometer, nozzle adjustment, nozzle pattern wheel, brake adjustment, hydraulic bench, flow control valve, overflow, storage tank with pump, valve, measuring tank level, and the last one is measuring tank. Okay, next we go for the experiment procedure. The experiment procedure for this pattern wheel experiment consists of 5 steps. The first one is make sure there is no water or no water from the hydraulic bench. The second one is flow rate is found out from the hydraulic bench, and rotational axle is determined by nozzle valve. The second one is the nozzle is positioned by adjustment. Next step is pump is turned on and the storage tank is filled with water. And the last one is nozzle will direct the jet of water to the pattern wheel. I think that's all from me for methodology and procedure. Next we go to the chapter 4, that will be presented by my friends. That's all from me. Thank you.
Assalamualaikum and hello everyone. My name is Muhammad Amin bin Muhammad Amar. My metric ID is MA18105. So today I will present to you about our experiment 5, which is the Pelton wheel, for the results and the graph. So next. this is our turbine characteristic curve with pressure 0.2 bar and Q 30.9. So this is the table that we have completed, which is we have managed to calculate the power output, the power input, and the efficiency of the turbine, and then with different rotational speed and the moment of the shaft. So the next one is the power curve with the pressure. So we have calculated 14 of it, and the rotational speed with power output. And then the next one is I am going to present to you about our graph, which is for rotational speed versus the moment of the shaft. So from here, this is our graph that we have gotten, that we have plotted, which is the rotational speed RPM against moment of the shaft nanometer, Newton meter. And then from the graph, the moment of the shaft, which is Newton per meter, decreases when the rotational speed RPM increase. So the next one which is the graph for power output versus the rotational speed. So this is the graph for rotational speed against the power output. So from here we know that the graph shows that the power output from the Pelton wheel will be decreased when the rotational speed increase. And then the next one is the efficiency versus the rotational speed, which is this is the graph for the efficiency versus rotational speed, which is rotational speed against the efficiency in percentage. So the graph shows that the efficiency will be decreased when the rotational speed of the Pelton wheel increase. Then the next one, which is the power curve. So from the graph, we know that the power output of the Pelton wheel for the flow rate, which is 31.5 liter per meter, is higher compared to the flow rate 30.9 liter per meter at the rotational speed lower than the 700 RPM. But when the rotational speed increase or higher than 700 RPM, the power output for the flow rate, which is 30.9 liter per meter, is the highest compared to the flow rate 31.5 liter per meter. So that is all for me, and thank you.
Hello, my name is Dr. Richard Matulis. My metric ID is MA18146. Today, I will be mainly explaining about our group's chapter 3, which is discussion on our lab 5, which is the Pelton wheel efficiency. Okay. So first and foremost, there are several essential aspects of the Pelton wheel that may be observed from the turbine characteristics curve. According to our expectations, as the rotating speed of the Pelton wheel increases, the efficiency of the wheel should improve as well. This is due to an increase in wheel speed, which will boost the power output until it reaches its maximum efficiency before the efficiency begins to decline. However, based on the statistics, it appears that the efficiency drops continuously as the rotational speed increases. As a result, we know that the data collected has outperformed the rotational speed in terms of overall efficiency. It is believed that the decrease in efficiency is due to a reduction in the volume of water that is capable of heating the buckets, as the absolute velocity of the bucket is greater than the absolute velocity of the water. Next, in the power curves, a higher volumetric flow rate is used, which is 31.51 per minute instead of 30.91 per minute. The power output increases as the rotational speed of the bucket increases up to 610 rpm. The power output then decreases as the rotational speed continues to increase. The power output around 845 rpm then comes out as zero. This is due to the speed of the bucket surpass the speed of the water jet. The zero power output is caused by the water jet being unable to hit the turbine's buckets as it is now traveling faster than the water jet. I think that's all for the discussion. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashhani bin Aizlan, and I will like to talk about the conclusion from the lab 5. Okay, for the conclusion is, it can be concluded from the experiment that the performance and efficiency of the PELTON turbine at a different turbine characteristic curve operation condition is determined. As a consequence of the increased spinning speed of the PELTON wheel, the wheel efficiency should improve as well. The loss in the efficiency is due to the decrease in the amount of water capable of reaching the bucket. Okay, these are the reference that we use for writing the report. Okay, thank you. That's all.